Okay, Assalamualaikum and a very good morning to all. Okay, so in the previous slides, okay, in part one, we have looked into the wastewater management, okay, and then we have looked also into the physical, chemical, and also biological in general. Okay, next, in the previous video, we just learned about the physical and also chemical parameters, which only covers the inorganic part. So for today, in the second part of the video, we are going to continue under the chemical parameters, which is organic part. And then last one is the biological parameters. Okay, let's start with the organic. Okay, this one is under chemical parameters. Okay, usually organics is soluble in water and it comes from the natural sources and also human activities. For organic, it can be divided into two classes. One is natural and another one is synthetic. Okay, for natural organic, usually it comes from the decay product of organic solid. Whereas for synthetic organic, it comes from the wastewater discharge or agricultural practice. Okay, the organic also can be categorized based on the dissolved organic itself. The first one is the biodegradable and the next one is the non-biodegradable. So for biodegradable organics, okay, usually it can be utilized for food because it can be degraded. Okay, and then for organic material, usually it exists in the dissolved form. Okay, example such as starches, fats, proteins, and so on. Okay, for microbial utilization, okay, uh, it can be accompanied by the oxidation and also reduction of the process. So what is the difference between oxidation and reduction? So for oxidation, it involves the addition of oxygen to or the deletion of the hydrogen from the element of the organic molecule. Okay, whereas for the reaction, it is actually the opposite of the oxidation. Okay, so instead we are going to have an addition of hydrogen to or the deletion of oxygen from the element of the organic molecule. Okay, usually the most common term in the biodegradable organics is the BOD, or known as the biochemical oxygen demand. Okay, so it defined as an amount of oxygen consumed during the microbial utilization of organic. So how to conduct this test? Okay, what is the purpose of this test? Okay, the purpose is to determine the oxygen consumed from a sample. Okay, whereby we have a 300 ml bottle. It is a glass bottle. So we put the sample into the bottle. Okay, and then we seal it with the uh, airtight content. Make sure it is airtight. Okay, usually we use the parafilm. Okay, and then usually the condition is that we run in the controlled environment. So the temperature used is 20 degrees C in the incubator. And then we put it in the dark room, okay, in the incubator for 5 days. Okay, the purpose of why we put it in the dark room is to prevent the algae growth. Okay, because when we have the algae growth, okay, the consequence is we would produce the oxygen. Okay, so we want to prevent it, so that we put it in the dark room for 5 days. So the test is that you measure the oxygen on the first day where you prepare the sample. Okay, and then you put it in the dark room for 5 days, and then after at day 5 you take the sample out and then retest again. So that is where you get the difference in the amount of oxygen consumed. Okay, for this exercise we will do it in the class so that you can see more clearly on how to do this calculation. But actually this example is already in the textbook. For those who can get the textbook from your seniors, okay, we have this example. Okay, maybe you can read through first so that we can discuss further in the class. Okay, how to calculate the DO. DO stands for dissolved oxygen. Okay, the next part, okay, just now is a biological part where it is easily degrade. Okay, but for non-biological, it is the opposite of biological. It means that it is a very resistant to biological degradation. Okay, this example we have lignin acid, cellulose, and so on. Okay, usually the characteristic of the non-biological organic is that we have an extremely strong bond, okay, such as polysaccharides. And then many of the organic associated with petroleum. So, okay, this is oil and gas industry. Okay, it is a very toxic. Okay, some organics are very toxic. That is why it is a non-biodegradable, such as pesticide, industrial chemical. So, the petroleum is example of the industrial chemical. Okay, and also hydrocarbon. Okay, what is the drawback of this non-biological organic? Can cause extinction of animal species. So just imagine if you have the oil pollution due to the refinery process in the sea. Okay, so it will cause extinction to the species of fish and so on. Okay, and usually non-biological organic also is chlorinated hydrocarbon. Okay, so how to measure this non-biological organic? It is through the COD or the TOC. COD stands for chemical oxygen demand. TOC stands for total organic carbon. Okay, sometimes we can also use the GC, okay, gas chromatography, in order to find what is the specific organic compound's name. Okay, and then the value of COD usually is higher than BOD because more compound can be chemically oxidized rather than biological oxidized. For example, if I have the palm oil mill effluent, the POME, okay, the value of COD usually 2 times higher. For example, BOD in terms of concentration is 25,000 milligram per liter, but for COD, the value of concentration is higher. For example, we have a 50,000 milligram per liter. Okay, that is an example why COD is higher than BOD. Okay. For wastewater weight ratio higher than 3, okay, this one is higher than 3. Just the previous example, I just give you example of 2 times higher. Okay. Okay, it is assumed that some oxidizable material is not biodegradable. Okay, the table now shows the differences between the BOD and COD. Okay, so the first one is the definition. BOD measures biodegradable. Okay, COD measures biodegradable and also non-biodegradable. So it means that the COD can measure both. Okay, both types of organic. Okay, the next one, it uses the oxidizing microorganism. COD uses a strong chemical agent. Okay, because we have a chemical agent used together with the sample, okay, during the test for in COD. Okay, the next one, in terms of toxicity, BOD affected by toxic substance. COD, it is not affected. Okay, the temperature, BOD is not, BOD is affected by temperature, but COD is not affected. So you can see that the COD is COD is more powerful compared to BOD, more resistance. Okay, in terms of experiment duration, for BOD, usually we need 5 days of incubation in the dark room. Okay, so it means that after 5 days then only you can get the result. But for COD, you just need 2 hours, whereby you put the sample into the COD reactors. After 2 hours, you cool down, you have the titration, then you can get the result already. Okay, very fast for the COD. Okay, how about the accuracy? Accuracy for BOD is plus minus 10%. The COD, the accuracy is plus minus 2%. Okay, enough for the BOD. So the next one is the nutrients. It is very essential elements for growth of plant, animal, and also aquatic species. For aquatic species, the most required is carbon, nitrogen, and phosphorus. But in most cases, both nitrogen and phosphorus are the limiting factor in aquatic growth. Okay, the next part is the nitrogen. Okay, nitrogen is very important as an essential building block in synthesis of protein. because when usually when you have the nitrogen, we will use this nitrogen data to evaluate the treatability of wastewater. It means that we want to check whether the treated wastewater is it okay or not. Is it uh, can be is it precise or not? Okay, so that is the use of the nitrogen data, okay, in the wastewater. Okay, the next one, okay, oxidation of ammonia and ammonium to nitrate, okay, by aquatic microbes will result in the additional of BOD volume. Okay. Okay, tests for nitrogen in water commonly include analysis for ammonia, nitrate, and also organic nitrogen. Okay, it means that whenever you want to do the nitrogen analysis, these three, the ammonia, nitrate, and nitrogen will come together. Okay, so these three analysis, ammonia, nitrate, and also organic nitrogen, okay, so the summation of these three will give you the result of the nitrogen data. Okay, where control of algae growth in the receiving water is necessary, okay, because it is very useful in the removal or reduction of nitrogen in wastewater prior to discharge may be desirable. Okay, and then the unit for nitrogen, milligram per liter. So as you can see, the concentration that we use for COD, BOD, and then nitrogen, nitrate, okay, ammonia, organic nitrogen, all of this we use the concentration unit with this, which is milligram per liter. Okay, the next substance, okay, the phosphorus. Okay, phosphorus is typically the limiting nutrient in lakes and algae problem. So what is the problem now? Okay, when you have the phosphorus in wastewater, it can give you the bad taste and odor. Okay, sometimes the phosphorus, it can be toxic, especially to the farm animals. Okay, but if you have the concentration as low, even as low as 2 milligram per liter, it will interfere the coagulation in turbidity test. Okay, usually the phosphorus come from the fertilizer or detergents. And it can exist in variety of chemical form. So total P is normally measured. Okay, so it means that for phosphorus, we go for the total P. Total P means total phosphorus. Okay, enough for the chemical parameters. So the last part is the biological parameters. Under biological parameters, we are going to learn a lot about the bacteria, fungi, algae, and so on. Okay, so why, as an environmental engineer, you should know about this? Because it is very important for you to characterize the factor in wastewater treatment. Because when we deal with wastewater, you have, as an environmental engineer, you should know what is the bacteria, fungi, or algae, or viruses in the wastewater, because we want to know what is the effect, whether it gives you the positive effect or the negative effect, and how it help or it reduce the wastewater treatment process instead of adding the chemical. Okay, so the main microorganism of concern in wastewater, this is the most common one. We have the bacteria, fungi, algae, protozoa, viruses, and pathogenic microorganism. Okay, these are the most common. Okay, we have the types mean the shape. So it can be the spheroid, rod type, spiral, filamentous. Okay, and then these are the some of the most important bacteria. We have Pseudomonas, we have Sphaerotilus natans, Acinetobacter. Okay, so here we have each of these we have a purposes. Okay, for example, Pseudomonas reduce, okay, nitrate to nitrogen. Okay, and then we have Azintobacter, okay, store large amount of phosphate. Okay, very useful in phosphate removal. So this is a few example. You can read this. Okay. Okay, the next one, nitrosomonas. Okay, transform ammonium into nitrate, nitrate. And then we have nitrobacter, transform nitrate to nitrite. Okay, the most common coliform bacteria is the E. coli. Ini yang most common. Okay, and then the E. coli, it is an indicator for the presence of pathogen. Okay, of course we have the value indicator here. Okay, and then this is the shape. You can see sometimes it just like a rod. Okay. Okay, and then next we have a fungi, algae, and protozoa. So fungi, why it is important? Because it is used to decomposing organic matter to simpler form. Okay, and then algae. Okay, the presence of algae, it can be negative impact or positive impact. Okay, example of positive impact is that it is very useful in the oxidation of bonds. But for the negative effect, it can cause eutrophication phenomena and also can cause the taste and odor problem, okay, when decayed. Okay, and then the third one is the protozoa. Okay, this is very important in the purification of treated wastewater. So as I was saying in the first video, okay, you don't have to memorize word by word from this. So what is I have highlighted here is the key point that you should remember. Okay, so and then once you have a key point, you can create your own words as long the meaning is there. Okay, for us to understand and give you marks during MTA. Okay, viruses. All of us know viruses can give you major hazard to public health. Okay, and then not all, but some of the viruses can live as long as 41 days in water in the temperature of 20 degrees C and can cause lots of dangerous diseases. Okay, example, you have it can lead to the disorder of nervous system. Okay, the and also in infectious hepatitis. Okay, so finish about the biological parameters. Now we go to the water quality requirement. Okay, what is water quality requirement? Okay, water quality requirement, it is varied according to the proposed use of the water. Okay, water quality requirement means you have a certain standard, okay, that we should follow so that you can have a good quality of water. That is in other words. Okay, okay, represent a known or assumed need. Okay, as I was saying just now, we have a certain requirement, certain criteria that we have to follow so that you can produce a good quality water, for example, for drinking purposes. Okay, WQS, this is standard water quality standard, usually is set by the government. Okay, the next part is the water quality index. Okay, for water quality index, it gives info on water quality condition and trends. Okay, the purpose is to measure the degree of water pollution and tool in water quality classification. So it means that from water quality index, we can know what is the classification of the water quality. Okay, the easiest method to explain to the pollution level to the public especially. Okay, for example, remember we have water shortage in Selangor. Okay, so we measure the quality of water of the dam, the river dam, and then whether it is a good, bad, okay, poor, and so on. Okay. Okay, and then the last one will be the the last part of this slide is the water quality index. Okay, still the same subtopic. Okay, you have to remember that the water quality index will be different or vary from country to country. For example, the water quality index set by the Japanese government is different from the Malaysian government. Okay, and the measures general water quality condition and does not reflect the presence of toxic compound. Okay, so this is what you should know about the water quality index. Okay, and this is the fifth schedule. Okay, remember at the beginning of our topic 1 in the first video, I have talked about the standard A and also standard B. Okay, I have given you the example of BOD and also oil and grease value. So for BOD at 20 degrees C, for example, I give you 20 milligram per liter if you comply with standard A. But if you go for standard B, you can go up to 50 milligram per liter. Okay, for oil and grease, for example, standard A 1 milligram per liter. But if you go for standard B, you have the limitation of 10 milligram per liter, which is higher than standard A. So when to use standard A, when to use standard B, this one will be decided, okay, based on the condition. Okay, we are going to go through the example, okay, maybe in a tutorial. Okay, and then I guess this is the last slide, the second last slide. Okay, the sixth schedule. Basically, this sixth schedule represent the catchment area. Okay, catchment area, this is very important. Okay, showing the areas of the upstream of the surface or above the subsurface water supply intakes. Okay, catchment area, what you should have in your mind is that where is the location of the river dam. Okay, for example, river dam and also because why it is important for the catchment areas, because catchment areas will tells you, okay, where is the location of this river. Okay, and then what is the purpose of this catchment area. Okay, usually we will take this river, okay, for human consumption, especially in drinking water. Okay, I give you for example, Sungai Semenyih. Okay, the name of the river is Sungai Semenyih. Okay, the water supply scheme, it is coded under Sepang. And then location of the water intake, they show you in terms of longitude and latitude. Okay, so it means that all of this river, okay, is meant for the water supply intakes. Okay, so this river are called as the catchment area. Okay, catchment area means we really take care of this river. So make sure it comply with the standard, okay, WQS, water quality standard set by the government. Okay, we check for the water quality index, okay, whether it is good, bad, poor, and so on. Okay, if it is good, then only we supply the water to the human. Okay, but if it is bad, that is why we have to stop the production of water or supply the water to the human, and that is why caused the water shortage in Selangor before this. Okay, so that is one of the example. So you should know how to read this table. Very simple. Okay, so this table basically just to show you the name of the river and also where is the location in terms of longitude and latitude. Last slide is the tutorial question. Okay, so I hope that you can get or borrow from your seniors the textbook of environmental engineering. So these are the question number that you can get. You can do the tutorial 2.4, 2.8, 2.24, 2.31, 4.3, and also 4.4. So you have together 6 questions. Okay, for tutorial. But in the next class, it will be decided later whether it is still online for this week or we can go to the class, because some of your friends are still undergoing industrial training. So this one will be decided later, okay, for the next class for this week, only for this week. Okay, so with that, end of chapter 1. Okay, for chapter 2, I'm going to give you later the pre-recorded video Okay, because supposedly this week we have started with chapter 2. Okay, so thank you very much for your attention. Assalamualaikum.